Let's understand another part of this series, right, in which we are going to see the another question, that is 64 of minimum path sum. So this is also a question based on the you can say matrix style, right, as you can see here. So we have given a matrix m cross n as a grid here in this question, and we have to find the minimum path sum. That we will see how we will do that, right? So let's read the question. The question is saying that we have given m cross n grid, right, and that is filled with non-negative integers, okay, numbers, and we have to find a path from top to bottom, right, means from here to here we have to find the path, okay, which minimizes the sum of all the numbers along its path, and you can only move either down or right at any point in the time, okay. So previous questions was saying that we have to start from here and we have to go to the here, right, from top left corner to bottom right corner, and we have to find the you can say all the unique paths, right? But in this question it is saying that we have to find the minimum path, and that minimum path sum we have to require, right? Minimum path sum, right, means all the path you have as the sum, but we have to give we have to return the minimum path, right, of the sum, minimum path sum, you can say. You got it, okay? So let's read how to do that. So we have given this question in the example first grid we have given, and there is 7. It is saying that how we will do that. So 1 we have, then we have 3 we have, then we have 1 we have, so it will become what, 4 or 5 and 2 7, right? Other than this it will become more than this, right? So that's no problem, we'll see later, okay? So coming back to the approach, how we'll do this question, right? The brute force approach involves recursion, right? Because if we will do recursion, then only we can find the you can say child thing or previous things, you can say, right? Or to calculate the next thing, we have to know the two backward things, right? Like let's suppose if there is a cost of something, right, I and j, right? To find the cost of I and j, what we have to do, we should have the cost of what, I plus 1 and j, and another we should have what, cost at I and j plus 1, right? Either right and left, which one we have to take, right? That we will have to get it, right? And plus the current value, okay? So that's why you can see, to calculate the cost we have to get the current where we are, right, where we are, the current value, okay, and the minimum value that we are going to take from either left or down, right, that we are taking, okay. So this is for, let's suppose, left, and this is for the right, or either you can say no, not left, down, okay, down, you can say down, okay. So you can take as this one as a left or right, whatever matters, right? So we are taking two direction, this direction and this direction, down and right, okay. So in both of this, if there is 3 and there is 2, so which is minimum? This is minimum. That's why we are taking minimum from the x and y. Which one is minimum? Let's suppose x is minimum, then we will return x, okay, and the current value, whatever the current value we have, right? So that will come the cost of this one, okay. Let me clean this one. You got it, okay. So that's why it is saying that the brute force approach is very easy approach, because it involves the recursion approach, right? So for each element we consider two paths, the rightward and the downward, right? And we will find the minimum sum out of those two, and we need to take a right step, or you can say, or downward step, to minimize the sum, okay. So this is your formula. You can work on this one, right? As you can see here, this is to create the you can say brute force approach, okay. So let's suppose how we're going to do this. So this we are going to pass as an input as a grid, and we will calculate minimum sum, right? So this is the DFS function, right? I mean it will you can say recursive function, DFS function, you can say, that will pass from what, 0 0, I and j both are 0 0, okay. So we know that from I 0 0 we will go to where, either will go 1 0 or 0 1, right? These two directions we have to go, right? So to go for, you can see here, if I is 0, we are going to I plus 1, that is this one, and j plus 1, that is this one, right, this one. So both directions we will go and calculate which one is minimum. If we will get x here and y here, which one is less, that will come minimum, that is become minimum here, right? And the current value that we have seen here, right? that here. So that value, and the base cases will become what? This is the base case if I is equal to the grid length, right, and j is the length is equal to the length, right, means both are empty, right, and if I is at the last position, j is at the last position, means we have reached to the last, then we will return I and j. Okay, that's all. And in this case we are going to take each time to calculate each solution. As you can see here, right, we are going to two path m and n, right, so that's why two for each solution we are going to two sub question, right, and for that it will become 2 to the power m plus n and O of m plus n. Okay, let's me recap this one, so this will become a little easy for you. So to calculate any position, let's suppose we have this one as an array. Okay, so this is your 0 0, right, so from here either will go this direction or either will go to this direction. So the next direction will become what? Either 1 0 1, you can say, sorry, this will become what? 0 and 1, and this will become what? 1 0, right? So either you go this direction or this direction, whichever will come, that will become your answer here, right, this one. Okay, and that's why we are taking to calculate this cost, right, we will have to the current value whatever we have at here, right, whatever we have at here, that value, and the minimum, which one is minimum, that will come here, right, and that is why we are calculating like this. Okay, so initially you you have this data, right, as a grid we are passing, and 0 0 we are passing as a current position here, and we have to reach to here. Okay, so each time if this is m and this is n, we will go to m plus 1, right, and n will remain same, and here m and n plus 1, right, and so that this is the recursive call. We will calculate, means current state value, and the minimum between m plus 1 n and m n minus 1, right, because this is the, we are going to recursive, we are doing plus, we are not going to downward, right, means we are not doing minus, right, we are going to ahead, right, and that's why we are taking plus 1. Okay, so two questions is there. If we reached at the length I is equal to the length and j is equal to length, means this is empty, right, or yeah, you can say empty. In that case what will happen, the max value will return, and otherwise if it is we are at the last index, right, it means what? We have to return grid I and j. Or either you can say, if this is the length is I and j is equal to the m and n, that is your grid length, and column and row, means we have to return the exact value that we have at there this position, right. If there is only one cell, then we will return from here. Otherwise if this is very big, we will return the max of the integer value. That is different thing that will that you can understand, that these two are the base conditions. Okay, now coming back to the DP, right, dynamic programming. So we can use an extra DP of the same size as the original DP. As you can see here, this is your original array and this is your DP, right. So currently as you can see here, we have what? Three we have here, right, and either we will go to upside or this left side, right. Two way we have to go, right. So which one is minimum? Let's suppose we have here as a 2, so 2 is minimum. So current value is 3, right, that we are talking about. This grid value, grid at I and j, right, that is your 3, and we have what? Here we have 9, let's suppose, and here we have 2, just for understanding. Okay, so what will happen here? Which one is minimum? So 2 is minimum, right, and currently we have what? 3 we have. So we will choose these 2, 3 and 2, and we'll say the next value will come as a 5 here. Okay, so that we are going to see here. Okay, as you can see, similarly we will fill all the data, as you can see here, original DP, and we will reach to the last position, and we will have our minimum value, and then we will return our data. Okay, so first of all what we have to do, we will create one DP as an array. This is your m and this is your n, right. You can find the length m and n, and then you can create the DP array. Now from we are using top down, right, as you can see here, I have not mentioned this one, but this is top down, right? So we'll start m minus 1 and then we'll go to the equal to 0, means from down to we'll go to the top, right? Means top sorry, down rightward that we have, from there to we will go to the left top corner. Okay, so m is last length to the first length, and we'll go to the j, will also go to what, n last position, right? And to the j, means decreasing order will take for I and j, right? I and j is nothing but m and n. Okay, so if we are at the last index, right, and it is not equal to the grid dot length minus 1, let's suppose what we are talking about. So this we are talking about. Okay, means if I is at this row, okay, here, and j is not equal to the length minus 1, means this is not at here. So in this case, right, we are not talking about here, right? Means other than this, what we have to do, we will calculate dp I and j, right? Here we'll calculate I and j plus, right, grid, whatever that we have at grid, then we'll take what, j plus 1, right? Because j is not equal to the last one, right? If it is not as the last one, so it will not cross the border, right? And for the I and j, it will become I and j plus 1. Similarly for the j, right, it is j is at the last position at here, means this row, this column you can say here, and I is not equal to the grid length, right, here. In that case, what we have to do in the first row, this is middle of this one. Okay, so what will happen, the current value will take, but we'll take I plus 1 so that I will not cross the border, and j, right, similarly. So in this case, what will happening here, j not equal to the grid value, we are doing minus 1. If it is not equal to this and not equal to this, in that case only we will calculate what, the current value I plus 1, j plus 1, which one is maximum in the x and y thing, and the current value that will come here. And then other than this, dp at ij is grid at ij, and finally we'll return whatever we have at the top position, right? dp 0 0, that we will return, right? I think understood, right? Let's understand again. Means first we are from the top value of the row and column will start, and we'll go to the 0, right, decreasing order, right? We'll take row and column, we'll check each position if I is at the last position, last row, and j is at the last row, both case, right? So we are calculating in the different manner, the current value will take, and j plus 1 will take, and here I plus 1 will take. Okay, and if both are not equal to the last position, in that case only we'll take dp ij, will calculate, and we'll store at dp at j, this one. And other than this, we will directly store the value, and we will return dp at 0 0. Okay, so this is very easy, no need to worry about this one. Actually, what we have to focus here, if grid I is at last and j is not at the last, means we are not increasing I value, because this is already at the last position, right? And that's why increasing j only. If j is at the last and I is not at the last, means we are only increasing I. And if both are not increasing, right, both are not equal to that position, in that case we can increase I and j both, right? And we will find the minimum and the current value of the grid value, and we'll store here. So this is so easy question, right? You don't have to worry about this one. Okay, and you can traverse from downward to upward, and you can find dp at 0 0, you will give the answer. Coming back to the dynamic programming 1D, previous was the 2D, now we are going to see the 1D array. So how we'll find the answer? So in the previous case, instead of using 2D matrix of the dp, we can do the same work using dp array of that row size. Since for making the current entry, all we need is the dp entry for the bottom and the right element. Thus we start by initializing only the last element of the array as the last element of the given matrix, right? So the last entry is the bottom rightmost element of the given matrix, and then we will start moving towards the left, and we will update the entry dp and j. So what is dp and j? So dp and j will come from what, grid at I and j, whatever we calculate from the dp at j, and whatever j plus 1, right? So let's understand. So here we are going to create a dp1d array, and we'll take from the top row and top column. We'll do in the decreasing order, and we similarly loop will use if I is at the last row and j is not at the last column. In that case, what will happen? We will increase only j plus 1, okay, and we'll store at the dp. And other than this, if j last column, we are at the last column and not at the last row, right? In that case, we will increase what? No, we will not increase j, right? Here we are increasing j plus 1, but we will not increase j, right? Other than, we will everything will remain same, right? If both are not at that position, in that case, what we'll do? We'll use dp at j and j plus 1. This is x, your y. Which one is minimum? That will come and store using this value, right? And we'll store at the dp. Other than that, dp at j is grid I and j, and we'll return dp at 0, which is called minimum, right? So everything is easy, everything is same, right? Only you have to focus on here, right? dp at I is nothing but grid ij will store, and dp at j plus dp at j plus 1, okay? And dp of j we will store when we are not at the last position of I, means row. We are at the last row, and we are not at the last column, right? Then only you can see here, right? If I is at the last row, then we are storing what? dp j plus 1. If we are not at the last row, but we are at the last column, in that we will store at the dp at j, right? And other than this, if dp if I and j are not at the last row and column, then we will find the minimum of dpj and dp j plus 1. Which one is come as a minimum, x and y, that will come here, and we will store using the plus here, right? And this will give the minimum path. Other than that, we have another approach, that is dynamic programming without extra space. So in this approach, it is similar to this approach 2, with a slightly difference. What we have, instead of using the dp matrix, right, we can store the minimum sums in the original matrix itself, since we need not retain the original matrix here. Thus the equation now become is grid ij is grid ij plus the minimum between I and j, right? M plus n and m and n plus 1, okay? So we are updating, only this part will get changed here. As you can see, rest will remain same, okay? Rest will remain same, and we will return from here also, not at the dp, because dp is no longer here. In the next part of this video, we are going to understand the unique paths, right? And let's see in the this video, okay?